Hi, good evening all. I'm going to explain question number 10. It is a question based on chemical energetics. Chemical energetics is a part of thermodynamics. Let us solve this question. A student mixed 25 centimeter cube of 0.1 mole per decimeter cube sodium hydroxide solution with 25 centimeter cube of 0.1 mole per decimeter cube hydrochloric acid and noted a temperature rise. Look at this. There is a rise in temperature of the solution. So it indicates the reaction between sodium hydroxide and HCl is an exothermic reaction. So the energy has been given out during the neutralization of sodium hydroxide and hydrochloric acid. At that case, the temperature of water, that is the energy, has been absorbed by the solution and there is a rise of temperature that is about 2.5 degrees Celsius. So they are asking what is the enthalpy change of the reaction per mole of NaOH. So using the data, we are going to find out the enthalpy change of the reaction per mole of NaOH. Let us find out that. First, I am going to convert that 25 centimeter cube into ml. That is very simple. 1 centimeter cube is nothing but 1 ml. So 25 centimeter cube means that is 25 ml. And then 0.1 mole per decimeter cube is nothing but the 0.1 molarity, right? So I have taken that for my conveniency. But anyway, I will explain that why I have taken like that. First thing, look at this. There is a temperature rise in water. So here one data we have to take that. I think that data will be given to you in your examination. But anyway, that data is important. You have to memorize that also. What is that? Specific heat capacity of water, because the solution is having, that is the solution having the solvent water. So we need to know the specific heat capacity of water, that is 4.18 joule per gram. So here, the mass of water will be, you know about the density of water. Density of water will be 1. That is why the mass of water will be equal to the volume of the water. Total volume of the water will be 50 ml. So 50 ml, that will be equal to 50 gram, because mass and volume both are same in that case. That in that case of water. That is why I have taken that mass of water as 50 gram. Now I am going to calculate how much energy has been used to raise the temperature of 2.5 degree. So delta H, the formula for that one will be MC delta T. Look at this delta T they have given. Some of you may convert that 2.5 degree into into some Kelvin, right? But please don't convert that into Kelvin. Always temperature should be converted into Kelvin, no doubt on that. But temperature change, that is delta T. So if we are taking that change in temperature, degree Celsius as well as Kelvin will give the same result. So not necessary to convert that change in temperature into Kelvin, because whatever may be in degree Celsius or Kelvin, both are having the same value when we are considering the change in temperature. That is why take that as 2.5 itself. Not necessary to take that is change that unit into our SI unit. That is, you may think like that. The SI unit of temperature will be Kelvin, so we have to convert that into Kelvin, but it is not for delta T, because delta T will be same for in Kelvin unit for temperature, in Kelvin unit as well as Celsius unit. So take that, like they take as such. So mass will be 50 gram and the specific heat capacity is 4.18 into 2.5. So if you are calculating that, I think you will get 522 something. Yes, 522.5. So 522.5 joule energy has been used to raise 2.5 degrees Celsius. So this much of energy has been released by the reaction of sodium hydroxide and then HCl. So that much of energy has been released. That energy has been used by the solution and it has raised its temperature up 2.5 degrees Celsius. So we have to calculate that energy for mole, 1 mole. But what actually 522.5 here? The number of moles of sodium hydroxide used in this reaction will be, how I can calculate that one? It's very simple. Molarity is equal to number of moles divided by volume of the solution in liter. So number of moles, how we can calculate that one? Molarity will be 0.1 and volume of the solution in liter will be 0.025. So the number of moles will be 0.0025. So here it clearly indicates this much of moles has been used to raise the temperature 2.5 degrees Celsius. So 0.0025 NaOH released 522.5 joule energy. Then 1 mole of NaOH used 522.5 int into 1 divided by 0.0025. So finally we will get 2,99,000 joule per mole of NaOH. So if you are converting that into kilojoule, then 209 kilojoule per mole. So that will be the answer. Hope you have understood that one. Thank you.